didn't record the first one. So we have updated the calendar way back here in the back. And I want to draw your attention to it because I want to keep reminding you of things this week. So today we'll take a formative, but we'll take it at the end of class, not the beginning of class, because then that way we're not running that. Worry about that. Okay. So today we're going to finish off that note sheet that you guys got. Tomorrow, exponential models by changing a percentage. We'll deal with some notes. Logistic models and graphs on Thursday. And then over the weekend, we're going to have some videos and a note sheet for you to fill in and watch. And so those videos will be posted probably tomorrow on Canvas. And then you'll have to watch them and fill in that note sheet at some time before class on Tuesday. I know that this weekend is kind of big for some people, what with HOCO and everything. So you have to just get those videos done before Tuesday. And the videos are not very long. If memory serves me right, usually we try any videos that we watch, we try and keep them under 10 minutes. Sometimes we might keep over and go like to 12, but that's it. And I think that there's two, I don't remember exactly how many videos. There's either 2 or 3. So we're talking a half an hour of stuff to watch. So nothing too major. Okay? So we've got that going on this week and then leaking into next. Okay? So yes, we are taking a formative today, but you're welcome. You get to use your notes on it. Ready, steady, go? Let's do this. So on Friday, you were working with some partners and or yourself, and you were dealing with this stuff. So these are the graphs on the back side of page, or on the bottom of page 2. Okay? And I just want to point out a couple of things. So the first thing is that you want to get your key points. You want to get those key points. So you want an exponent of 0 and you want an exponent of 1. So in this particular case, I would choose 0 and 1. Down here in number 3, I would choose -2 for my x value, and I would choose -1 for my x value, because that gives me an exponent of 0 and of 1. And you want those because those are the easy ones. Anything to the 0 power is 1, and the base to the first power is just the base. So those are nice and easy, even in fraction form. Now, you could also go here like in number 2, you could choose 0 and you could choose -1. Because then that's going to take that exponent, or that negative exponent, remember, takes that fraction and flips it over. Okay? So you could choose -1 there also. Okay? So those, just to make it, you want a true mathematician. People always laugh at me when I say this. True mathematicians are lazy. We always look for the easiest to do. Okay? Always. So make it easy on yourself. If there's a formula, we're going to use it. If there's a shortcut, we're going to take the shortcut. Okay? The other thing that we need to talk about is the horizontal asymptote. Now, the horizontal asymptote is normally y equals 0. And what you're looking for is anything that comes after the exponented term. Or sometimes it might even be before, but it's added or subtracted to that exponented term. Okay? So you get that. If there's nothing in this green area up here in this equation, then it's 0. Y equals 0 is my horizontal asymptote. If there is something there, then that whole entire graph gets shifted vertically. So like in number 3, it gets shifted down 7. So the horizontal asymptote would also go down 7 to y equals -7. In number 4, it would get shifted up to the go to y equals 2. Okay? Questions, comments, concerns, clarification? Good times with that. Okay. So today, then, let's talk about E, the exponential, or V. Notice it's the is capital X, so then it becomes V, like the Ohio State University. Anyways, can't tell you the Ohio State entity because they say in higher levels of mathematics, which you are now in, space E is the primary exponential function because it makes things simpler. Okay? On Friday, you realize, and we'll go over this in a little bit. On Friday, you realize, like, you know, if your base is between 0 and 1, then it's a decay. If it's bigger than 1, it's a growth, and all that stuff. With E, it makes things a little easier. Okay? So the number E is an actual number. It is 2.7182819 something. I don't know what it is after that. It is an actual number, and it's close to 3. Okay? The number E came to importance in the 1600s with Napier's work with logarithms, as well as Bernoulli's work on continuous compounding. I don't know if you ever heard the equation A equals PERT. Okay? So basically, when you put money in your bank account, it's continuously compounded, and so it's on what's called PERT, okay? Principal times e to the RT power, rate times time power. Okay? Bunch of other mathematicians also work with it. Okay? So what we're basically talking here is we are basically talking about f of x equaling e to the x power. So we want to graph that. Well, that's going to be 2.71828 to the x power. From your work on Friday, what can you tell me about that graph without even graphing? What do you got? At y equals 0? Yep. We got a horizontal asymptote at y equals 0. Okay. What else can you tell me? It's a growth, right? Because my base is bigger than 1. Okay? So it is a growth function. Do we know any points that it goes through? 0, 1. Okay? Because if I plug in 0 into that function, anything to the 0 power is 1. Do we know another one? At 1. So 1 and then 2.71828. And that would be like right in there. Love it. Okay. So if E is always, and E, no matter what, no matter where you go in the world, no matter when you are in the world, no matter anything, E is always 2.71828 such. Okay? Always. No matter where you are. So if that's the case, how do we change the rate to make it be a decay or a growth? Because it's growing right now, but how do we make it become a decay? What? Negative. Not a negative E. Where would the negative sign be? Ooh, that's a great question, right? On the exponent. Yep. Yep. So it's controlled in the exponent. All right. So exponential functions that use base E have the general form of f of x equals a times e to the kx power, where the rate of growth or decay is controlled by that variable k. Now, here's the cool part. You got it on Friday. You got it on Friday. Okay? So here's the cool part. So for growths, k is positive. So if k is positive, then we have a exponential growth. We'll go through the point 0, comma a now, because we've got that a factor in it. Usually it's 1. We'll still have a horizontal asymptote at y equals 0. You got it on Friday. You got it on Friday. And we'll all be good. Okay? If k is negative, then we have our decay. Still going through the point 0, comma a. Now, here is the question of questions. Why? Why is this true? Talk to me.
So when the exponent is negative, that means you have to flip the thing, your base. So the base is already above 1 because e equals 2.1. So that means that when the exponent is negative, it's going to flip it so that it's a fraction.
And that fraction is still going to be positive, right? Exactly. Okay. So what happens here, or in a visual sense, so if we've got e to some negative number, because that's what it would be, having a negative k value up there, then that becomes 1 over e to the positive number. And now that fraction is between zero and 1, which means decay. It actually is really nice because you don't have to worry about what the base is now. The base is always going to stay the same. You just got to look at the positivity of the exponent. If it's a growth, it's positive. If it's a decay, it's negative. So let's compare the two. Let's compare Friday to what we just learned. Okay. So on Friday, we learned that if it's a growth function, then our b is greater than 1. What we just learned is it's a growth function if k is positive. On Friday, we said it's a decay if our base was between 0 and 1. And now we're saying that if k is negative, it is. Couple of thought-provoking questions. Question number 1. Can b, the base in the left one from Friday, can b be 0? Can our base equal 0? No, because then our function would just be 0 the whole time. Okay? Can our base b from Friday be equal to 1? Can it be equal to 1? No, can't be equal to 1 because it again would be a constant function. Okay? Today, E is E. We can't change that. Can K be 0? No, because that would be a constant function again, right? Where it would just be y equals A the whole time through. Okay? So we can't have that. Okay? So we can't have those. If my exponential function is of the form a times b to the x, then growth or decay is controlled by b. If b is greater than 1, it's a growth. And if b is between zero and 1, from today, first off, there's a typo right there. If k is positive, it's a growth. And if k is negative, it is a decay. Okay? Let's go to work. Let's do some. Let's sketch these. Okay? So, example number 1 of the sketch shown there at the bottom. Start with the horizontal asymptote. Has the horizontal asymptote been shifted? No, so it stays at y equals 0, right? So let's draw that in first. Next question. Growth or decay? Growth or decay?
It's positive.
The exponent is positive, right? It is 0.5, just so you know, you gotta use your young eyes to see that it's 0.5. But that is positive, so it is a growth, so you can draw yourself a growth function. Give me a point that it goes through. 0, comma, what? Luke, you got it back there?
0, 4.
0, comma 4? Do we agree with 0, comma 4? If I plug in 0, 0.5 times 0 is 0. E to the 0 power is 1. 1 times 4 is 10. What would a good x value be to try this one? 2, right? Because 1/2 times 2 gets me an exponent of 1. So instead of trying 1 here, I'm going to try 2. Okay? 1/2 times 2 is 1. E to the first power is approximately 2.7, right? 2.7 times 4 is approximately 10.8. Okay? Example number 2. Horizontal asymptote. Shifted or stayed? Shifted which way? Up 1, right? Growth or decay? Decay. Point that it goes through. 15. Negative 2 times 0 is 0. E to the 0 power is 1. Times 14 is 14. Plus 1 is 50. Okay? What would another good point to choose be? Negative 1/2, right? Negative 1/2 times negative 2. 1. 1 e to the first power is e like 2.7, right? Okay? Which is close to 3, right? 3 times 14 is 42. 42. 42. 42 plus 1 is 43.
So when it's like a bigger number, do you want us to like round it to 3?
If you're not using a calculator. I mean, if you actually typed it out on a calculator, 14 e to the first would be, actual number here would be 39.0559. You know what I mean? But for the graph, we can go ish. Okay? questions, comments, concerns, clarification. Good times. As I said, the rest of the day today, we have a formative to take. Good times. Okay? And so we will, we'll do that now. Again, you get to use, it's a formative on matrices, and you get to use your notes. So as you have your, you can use whatever you got